Hi, my name is Olaf Wilmsmeyer and I'd like to talk to you today about UHF RFID in metallic environment. No, I don't like to speak about too much about reflecting signals and how to make sure that you're not accidentally reading transponders which are not in your spot. Because I'm here today with my favorite antenna, the LOCFIELD antenna, which are already installed behind me here on this yellow string, the yellow rubber string in front of a big metal wall. Maybe you have already heard about the LOCFIELD antenna, which is a special localized UHF RFID antenna which is generating a read zone around the cable like a tubing, and this tubing is even following the shape of the antenna, so you have a lot of flexibility to generate exactly your read zone. Today I'd like to demonstrate what does it mean if you install it really in front of a metallic wall or in a very heavy-duty metallic environment. So in the end, such a metallic wall is just a ground plane from electromagnetic point of view, and due to the special physics or due to the physics of this special antenna, of course the physics is not special, the energy is gone more or less into the ground, because the energy always tries to find a way to go to the electromagnetic earth, and this is the case here in front of a metal wall. The same you would see if you would install it on the floor. So if you tried the first time this antenna, maybe you would lay it down on your floor in the office, and then you will find a similar effect. So that means the read range is not that much due to the situation that the LOCFIELD antenna is that close to the electromagnetic earth. So what does it mean? For this kind of purpose to demonstrate, I have a FIC reader here with me, an up-to-date UHF RFID device which are configured up to 1 watt output power, so 30 dB. And I have some duckbone transponders, which I have here in my pocket, which is, I guess, a very common transponder and everybody is familiar with. So whenever this LED is turned from green to blue, we have a detection. So whenever it's blue, it is reading. And let's see what we can see. So I have to get pretty close to the antenna, as you could see. So something like, I would say something like 10 to 15 centimeters, which is 150 millimeters, of course. So how to increase the reading distance? Well, it's easy. I just need to increase the distance to the metal, and I can do this easily due to my fixation here. And let's see what happens if I'm increasing it just slightly. So I would say right now I have everywhere roughly 10 millimeter distance to the metallic surface, and let's see what happens to the reading distance. As we could already see, instead of 15 centimeters, we have now already 30 to 40 centimeters, I would say. Even if I go out of the field and come back, let's see, yeah, again, yeah. So as you can see, just increase the distance to the metal to 10 millimeters, and we have a pretty good compact read zone around the cable. And due to the physics of the LOCFIELD antenna, we don't need to take care about that much about reflections and so on. So the read zone is really compact around the cable itself. If you would increase the distance even more, then you would see that the metallic wall, the ground plane, has I would say no impact to the field at all. So I can demonstrate this. I have some spacers here with me, and I put it underneath the yellow string, and so that we have a minimum 50 millimeter spacer in between. And let's see what does it mean to the reading distance. Well, as you could already see, the read range is dramatically increased, something like a meter reading distance we have right now with the 1 watt output power at the reader side. So if you like to increase it, you can even increase the output power within the reader. And then you would see maybe in the end up to 2 meter read range easily with a LOCFIELD antenna. Of course, moving objects are always better detected than static objects. What kind of experiences you made already with a LOCFIELD antenna? Maybe in similar applications where you have a lot of metallic around. What other ideas you have in mind or questions, please feel free to share here on YouTube, on social media, or send me an email.